Hello everyone, this is Anurag Kumar from Department of Civil Engineering, Dayalbagh Educational Institute, Agra. Today we will study about Farakka Barrage. So, firstly we should know about the Farakka Barrage. In 1951, India announced intentions build a barrage across the Ganges 10 km from the Bangladesh border. The barrage diverts water into the Bhagirathi-Hooghly River to flush out silt and increase navigation accessibility to Calcutta. The barrage was commissioned in April 1975. This barrage gave India control over Ganges flow into Bangladesh during the dry season. In the spring of 1975, India withdrew 40,000 of the 55,000 feet cube per second of water from the Ganges. There were disastrous consequences of Bangladesh. So here we can see the beautiful pictures of Farakka Barrage. Background on the Ganges River and surrounding area. The Ganges system has the third largest discharge and the largest sediment load in the world, 10,86,000 feet cube per second and 1.84 billion tons a year respectively. The Ganges runs 2,500 miles with a basin of 9,243 miles square shared between India, Bangladesh, Nepal and China. In 2003, the basin was home to 405 million people, 346 million people in India, 19 in Nepal, 40 in Bangladesh. Here we can see map of Ganga's basin, map of the Ganga's river and tributaries. Brahmaputra and Ganges rivers discharge hydrographs of 1981. Brahmaputra and Ganges rivers. The source of the Ganges lies in the Himalayas. It is fed mainly by glacial melt from April to June. Flow is severely seasonal. The heaviest flow occurs during monsoon months, June to October, which brings 85% of all rainfall to the area. Droughts are common in the dry season, when the Ganges flow into Bangladesh is only 55,000 feet cube per second. Water is desperately needed in the dry season for crop irrigation. Bangladesh experiences widespread flooding during the monsoon seasons. Purpose of barrage. The purpose of barrage is to divert 1100 cubic meters per second of water from the Ganges to the Hooghly River for flushing out the sediment deposition from the Kolkata harbour without the need of regular mechanical dredging. After commissioning the project, it was found that diverted water flow from the Farakka barrage was not adequate to flush the sediment from the river satisfactorily. In addition, there are regular land bank collapses into the Ganga river due to the high level backwaters of the Farakka barrage. Substantial highland is already converted into low level riverbed, causing displacement of huge population. The water diverted from the Farakka barrage is less than 10% of Ganga river water. Farakka barrage project main objectives: to divert adequate quantity of Ganga water to Bhagirathi Hooghly river system, the 38-kilometer long feeder canal for preservation and maintenance of Kolkata port by improving the regime and navigability of the Bhagirathi Hooghly river system. Second is the increased upland supply from Ganga at Farakka into Bhagirathi reduces salinity and ensures sweet water supply to Kolkata and surrounding areas. The rail-cum-road bridge built over Farakka Barrage across the river Ganga at Farakka establishes direct road and rail communication link to the northeastern states with rest of the country. The Bhagirathi, the feeder canal and the navigation lock at Farakka form part of the Haldia-Allahabad Inland Waterway. In other words, we can say National Waterway 1. Structural design of Farakka barrage components. First one is forces acting on barrage. First force is buoyancy and second force is wind forces. Third type of forces due to the water current. Fourth force is differential hydrostatic pressure with the gate of one bay open and the adjacent bay closed. Fifth force is seismic forces, and sixth is hydrodynamic forces due to the seismic conditions. A pier shall have to be designed as a reinforced concrete column, and IS 456-2000 may be followed accordingly. For the design of other components of a barrage project like divide walls, abutments, flank walls, return walls, etc., we should use IS 11-130 1984 may be followed. Construction of concrete barrages. Barrages are nowadays made of reinforced concrete and designed as raft type structure which are light in weight compared to storage dams. The design of barrages is done by accepting some calculated risk, and hence it is important that the construction of such a structure is done with great care and there is no room for construction failure to occur. In this section, the important steps for a careful construction of barrage is explained, and further details may head from Bureau of Indian Standard Code IS 1150 1993 Construction of Concrete Barrages Code of Practice. Construction planning. The construction planning for any structures can be broadly classified under two heads. First one is infrastructure planning and second one is procurement planning, and is applicable to barrage construction also. It also includes the finalization of a program of works and intermediate review of the program with the actual work going on the field. These points are briefly explained below. First one is infrastructure planning. This aspect of planning needs to ensure approach roads, power and water supply, workshop, stores, aggregate processing plant, concrete patching and mixing plants, camps and work sheds. It also requires the establishment of other amenities such as market, schools, medical facilities and other social and cultural needs of the field staff and workers. The planning should be carried out to the extent possible before the work starts so that the uncertainties and delays in execution of work and precise time estimates for the job planning could be evaluated. This requires the storage of various construction related materials like explosives for blasting rocks, cement for construction, steel sheet piles, structural and reinforced steel aggregates. The construction equipment necessary to execute the work have also been procured along with adequate spare parts and accessories. Activities of Farakka Barrage project. Operation and maintenance are 200 to 45 meter long barrage across river Ganga with 109 bays and a head regulator with 11 bays. A 213 meter long barrage across river Bhagirathi at Jangipur with 15 bays. 38.38 km long feeder canal with carrying capacity of 1133 cubic meter. Navigation locks at Farakka and Jangipur. Calendary regulator lock and other infrastructures. Activities of Farakka Barrage. Left efflux bund of Farakka Barrage 33.7 km in length, right efflux bund of Farakka Barrage 7 km in length, and efflux bund of Jangipur Barrage 16.31 km in length. Two rail cum road bridges and two road bridges across the feeder canal. A number of regulators at different locations situated in Murshidabad and Malda districts of West Bengal. Bagmari siphon at RD 48.00 of feeder canal. Ongoing activities of Farakka Barrage project. FBP has taken action for replacement of distressed gates in phased manner considering working limitations. For example, access to installation site through piers only, double line busy railway corridor, stretch of NH34 over barrage, and working in limited space in flowing water conditions. Works of replacement of six old gates were taken up during 2012-13 and the work has been completed. Strengthening of seven old gates was taken up during 2013-14 and the work has been completed except painting of gates. During 13-14, replacement of 33 old gates were also taken up. Out of these 33 gates, 15 gates have been replaced by new gates during 14-15 and another 5 gates have been fabricated and are ready for erection at site. Servicing and maintenance of other hydromechanical components, hoist, central drive unit has also been taken up during 14-15 and is in an advanced stage of completion. Two steps of stop lock gates have also been procured during 2014-15 to meet out any exigency. Action for administrative approval of competent authority for replacement of remaining gates in a phased manner is also being taken up. So here we can see organizational setup of Farakka Barrage. Circle 1, Circle 2, Circle 3 all are explained and uh, you can see every part by stop the video. Negotiations between India and Bangladesh. India and Bangladesh were unable to reach a water agreement in 1975. In 1976, Bangladesh failed to involve the US nations. In 1977, a 5-year water sharing treaty was reached. This treaty gave Bangladesh 80% of Ganges flow during the dry season. This was followed by two memorandums of understanding lasting through 1988. These did not include a minimum flow into Bangladesh. No further agreements were reached from 1988 to 1996. India withdrew 40 to 45,000 feet cube per second from the Ganges every dry season of the period. In 1996, the two countries reached a 30-year treaty. This treaty dictates that Bangladesh receive a minimum flow of 35,000 feet cube per second from January to May. The relationship created by the 1996 treaty resulted in further agreement between India and Bangladesh. Area dependent upon Ganges flow according to the government of India and according to the government of Bangladesh. We can see this easily from the maps. Consequences of the barrage on India. Little silt was flushed from the Bhagirathi River. Calcutta has declined as a port city. Consequences of barrage on Bangladesh. Increased salinity of soil and water, decline of soil quality and crop yields, shrinking fish population, decline of fishing villages and loss of livelihoods, decline of mangrove forest, increased erosion rates and sedimentations, increased salt water intrusion, more severe flooding during the monsoon season. Direct damages are estimated to be 3 billion US dollars. Here we can see images of flooding in Bangladesh due to Farakka Barrage. Impact of Farakka Barrage and water diversion through feeder canal. Impact on stream energy, impact on river channel or interception of the flow channel changed from straight to sinuosity. Impact on river discharge, impact on sedimentation, widening of the river and increasing length, impact on bank erosion and displacement, impact on groundwater table, tendency to bypass the Farakka barrage along Kalindi Mahananda. Post-Farakka situation effects at a glance. On upstream side, interception of the flow channel changed from straight to oblique. Sedimentation is around 640 into 106 metric tons per year. Reduction of the cross-sectional area, declining slopes of the long profile, widening of the river and increasing length, increase in flood frequency and magnitude, severe bank erosion and displacement, rising groundwater table, tendency to bypass the Farakka barrage along Kalindi Mahananda. On downstream side, land reallocation from right to left, population displacement, Indo-Bangladesh border dispute, falling ground water table, communication linkage, threat to Farakka Barrage at Fazilpur Point. Effects on biodiversity. Impacts on biodiversity of flora and fauna were the main focus of this study. Nevertheless, other factors like salinity, sand hazard, underground water table, soil fertility were also discussed as these factors are related to the biodiversity. Changes in floral biodiversity, floral composition, crop productivity, intensity in crop cultivation, plant disease, changes on fauna diversity. Impacts on bird population not visible anymore. Kang, Shalik, Dahuk, Tia, Badami, Rajhans visibly less frequently. Sharash, Masranga, Borosada Bok, Chakha, Balihans, Chatak, Chapukhi. On aquatic animals not available. Dungfish, Pangus, Bagar, Gregorial. Rarely visible, chital, fish, ilish, pial, banspata, pabda, many, ud, sisu. Long-term situation, India and Bangladesh should jointly approach Nepal for cooperative development and management of the Ganges basin for construction of high dams for generation of hydropower and augmentation of the dry season flow. Basin-wise development and management plans should be taken for the Brahmaputra, the Ganges and the Meghna within a time frame of 25 to 30 years. Short-term situation, existing 30-year agreement should be reviewed and a guarantee clause should be included. Within the concept of the development and management of the Ganges basin, there should also be an agreement on sharing of the Ganges water at Farakka for a period of 5 to 10 years. The sharing agreement should also be reviewed after each 3-year terms, keeping in view for future development of the Brahmaputra and the Meghna. A feasibility study of the both rivers should be carried out. Solutions in brief. India's preference is to negotiate water sharing bilaterally to augment water flow in the Ganges during the summer and artificial channel connections to the Ganges and Brahmaputra between Sirajganj and Veramara. Accumulation and dispersal of sediment and water ensuring growth of delta, re-excavation and reoccupation of abundant distributaries of the major rivers would re-establish already disrupted equilibrium of the hydrodynamic system due to upstream diversion of the canals. Thank you very much. I hope this video is informative for you. If you like my video, please click the like button and subscribe my channel.